So hello everyone, hope you're doing good and welcome back to my channel. Today we are at day 22 of the May Daily Leetcode Challenge. We are almost about to complete the May Daily Leetcode Challenge. So congratulations to you if you have made it till here. Today we have again a medium level question in front of us. Like last 3 4 days we had questions on graphs, but now it's a different question. Let us see what it is. It's question 347, top k frequent elements. Okay, so let me give you one hint here. Whenever you say something like top k, okay, these things indicate that it's a question on heap. Okay, it's application of heap. Let me make it very clear to you. Whenever you hear these things, the hint that you should be getting is it's all about heap. So if you are aware of what heap data structure is, you can implement it directly. It's a direct application of that. If you don't want to see, there are inbuilt data structures as well. If you talk about C++, if you talk about Python, there are inbuilt data structures as well, where you can be using it directly. Okay, like in terms of C++, in the STL library, there is direct way of to implement stacks. Sorry, heap. So that you can do. But in this question, we'll see another easy way, another fast way to do it, and let's see what it is. So first, let us go to the question. It's given that see, you can see we are given a integer array first, which is called nums, and we are given integer k. Okay, two the inputs are given to us. Okay, given integer array nums and integer k, return the k most frequent elements. What we have to do is see in this example, one is present three times, two is present two times, and three is present one time. Okay, so you can clearly see the most frequent element is one, the second most frequent element is two. Okay, then the given k is two. That means we have to return two most frequent elements. Okay, two most frequent elements. What are the two most frequent? First is the one, next is two. Okay, these are the ones. Okay, coming to second example, they are asking most frequent element. Okay, so there is only one element, so obviously it's going to be the most frequent, so answer is same. That is the basic idea. Here you can see one thing here. They are asking you to code like see your algorithm stack complexity must be better than or equal to n log n. Okay, where is the size of the array. So they are giving this as a benchmark. We have to code a solution based on that. Okay, so let us see what we can do. See, there are many ways to do it. As I said, you can implement directly heap. See, either you can use inbuilt data, inbuilt way of implementation of heap, or you can code it on your own. If you have learned how the heap works, what are the sub functions for it, you can do that. But in this approach, we'll see a different how we can do it differently and quickly. Okay, because if it comes in online assessment, and if you don't know how to implement it on your own, and suppose the libraries, which are inbuilt libraries, are not usable in your coding environment in the online assessment. Okay, that happens sometimes. Okay, for example, in Python there are some libraries. Okay, in the coding environment you may not be able to import it. Okay, it will show some error because they're not available to buy basically. In that case, you should be knowing how to solve it, in a manual way. Okay, so here you will see that how to do it. What I'm creating a dictionary called frequency. Okay, FIQ, frequency. Okay, so whenever I say dictionary, it basically means a mapping. Okay, here there's a mapping between key and a value pair. Okay, and that's what it is. I will print and show you as well. So what I'm doing is I will go through my array. Okay, I'm going through my nums array. I will return each of the elements. Okay, I represent each of the elements. I will check if my I is present in frequency. Obviously initially it will not be present, so what I will do is I will create a key for I, and I will allow the value 1. That means I is present one time. Okay. And the next time when I is seen, this will be executed. What I will do is for that particular key, I will increment its value. So what I'm ultimately doing is for also for example here you can see 1 is present 3 times. So the key will be 1 and the value will be 3. Okay. That is how it is. Let me print and show you how it works. Okay. Just see the first print. Okay. How it works. You can clearly see this is the dictionary or mapping, however you call it. See here, one represents the element one, okay, present in the array 3 times. Okay, here two represents the element two present in the array 2 times. Okay, here the three represents the element three present one time. That is the basic idea here. Okay, for this we spend O of n time complexity. Okay, so this was all about frequency. Next, what I'm doing is I will extract all the keys out. Okay. So this is how I'm extracting the keys out. What I'm doing is I am see frequent dot keys. It will return the keys of this particular mapping. Okay. And I am like uncovering it or enclosing it, encapsulating it in a list. So the final output will be list called nums present. Okay. So what it will happen is just let me show you this. So see here one, two, and 3. Okay, these are the keys here. Okay, they will be simply extracted and they will be like present in a like enclosed in a list. Okay, and I'm calling it nums present. It will tell me the unique numbers present in my nums array. Okay, it will give me the unique numbers. Okay, only 1, 2, and 3. Okay, now I will sort it out. Okay, I will sort it out. How I am sorting? See, I am using a lambda function. Lambda function means uh, lambda means like I'm not passing a function name, just I'm passing a function body. What it means is, see, idea here is how to sort for, see, for each x, how you should sort it. You should sort it based on its frequency in the mapping FREQ. What it means is, see, for example, my list will have these things. Okay, 1, 2, and 3. Okay, these are the things which will present in my list. Now sort it based on the order such that, based on these values. Okay, so 1 will be placed such that it will be based on the value 3. Okay, so after sorting it, let me print and show you and what it will be before sorting. Okay, so this is the case before sorting, this is the case after sorting. Okay, what it means is the one having the higher frequency will come at the last. Okay, so see, this was the case initially. Just simply values were here. After sorting what means is, see, you have to sort. See, that means for each key, sort it based on its value in the frequent mapping. So for this particular key, what you should consider the value is this thing. For this key, what you should consider the value is this. Okay, that's why I'm passing it a lambda function. What I'm doing is, for each x, take the value of frequency of x. Okay, and sort it accordingly. That is the idea. Okay, so then the last, so this is the most frequent element. Okay, this is the second most frequent element, and so on. Okay, so this is the idea. Now we have to pass the k most frequent elements. That means the last k elements from, that means last k elements. Okay, k elements from the last. How to do that? This is how I am doing it. Okay, I am passing the starting index as minus k. See, minus k means, see, this element is called minus 1. Okay, last index is called minus 1, second last index is called minus 2, third last index is called minus 3, and so on. So it will start from the kth element from the last. Okay, and till the last element. This is how it is, and I'm returning it. Okay, I will just quickly run and show you how it works. And before that, let me just comment out the print statement, because this will affect the, you know, uh, the performance of the execution. Yeah, you can clearly see it's clearing all the test cases. It's passing everything. Okay, so if you talk about the time complexity of the solution, it's going to be, see, we have to take the max of it. Okay, this is going to be O of n. This is going to be O of n log n. Okay, because sorting is n log n time, and we're using the inbuilt sorting. So yeah, the time complexity will be the max of the two, that is O of n log n. Okay, if you talk about the space complexity, so yeah, we are creating a, see, frequency will maintain the list. It's basically going to be uh, b- see, we cannot as such say it, but see, we are ultimately in the worst case scenario. Suppose all elements are extinct. In that case, frequency will have a length of O of n, and the nums of n, this also will have a length of O of n. Okay. So in the worst case scenario, if you see, it will obviously in the case in the side of O of n. Okay, that is the basic idea, and time controller is going to be this only. So often that was all for today. If you want to really like see this, it depends on what the intention of the interviewer is. Okay, if this question comes in interview, you have to act differently. If this comes in the online assessment, you have to act differently. If this comes in the interview, definitely you can call this kind of solutions, but they will also try to check your understanding of use. Okay, that is the basic idea. See, when they try to check the understanding of it, either you should be able to explain them, or you should be able to, like, solve them using the code. Okay, what are the sub functions of heap and how it is being done. That is the basic idea. So yeah, friends, that was all for today. If you want to, please do comment below, and let's meet tomorrow again. Thanks a lot.